So Brad, as people get started with printing, what slicer settings should they pay attention to?
Right, and you can use any slicer that you want. We use Cura here in-house, so I think the easiest thing to do is just, I will put Cura on my screen and go through the settings with you quickly.
Right.
And the settings that we modify are common to every slicer, so you can adapt these to whatever slicer you happen to be using. Okay, so what we're looking at is a piece of the NASA chainmail. We use this as a sample and we talk about it quite a bit. So we'll just use it on my screen. So there's the preview of the G code. Let me go through the modifications that we made, and they're relatively minor. People think that our filament is going to be very, very different from PLA, and it's not. So what we tell people to do is go into Cura or your slicer and just select a generic profile for PLA. Starting there, set up your basic settings. Layer height, common question. 0.15 is a good medium. Going past 0.2 can be challenging. You'll have, it's easy to get under extrusion. And you can do this, but we recommend that people just start at 0.15 and get comfortable at that. 0.6 millimeter nozzle is our recommendation for most of our materials. Let's see, what else do we have here? And then the rest of it, no change, same as PLA. Second up, and some of these are stylistic or just personal preference. I like to print with lots of walls, but you really wouldn't need to. It'll print fine if you just go back to the normal line count. And I am going to slice this a few different times because I'd like to show you exactly what this looks like.
Great.
Okay, so here's one of the elements on the corner, one of the links of this chainmail. And as we bring it down, and people's opinions vary on this topic, but I never ever 3D print something without going in here and doing this, just looking at it. Make sure that all of the moves make sense. Make sure there's nothing simple or dumb that you overlooked, anything like that. Just give it a sanity check no matter what. I just never hit print without doing this. Wall thickness, I mean, it's easiest if it's a multiple of the nozzle width. We're at 0.6, so 1.2 comes out nice and even, and this is the default. So there's really no other changes here. It's the standard PLA settings. Top and bottom, same, no modifications. Infill. Okay, this can vary somewhat by the shape of the part that you're working on. Thick walls need to be debound more slowly. So one thing that you can do is not print at 100% infill. Like if you had a 1 by 1 by 1 inch cube that you were using for calibration or something like that, that's a particularly challenging shape if it's solid, because the binders need to escape as a gas. So as your parts get thicker, slow down the debind process and give the gas time to escape. If you don't, you wind up with extra porosity. You'll have an effect that we call pillowing, which is essentially delamination between either the layers or the lines. But go slow and it's not an issue.
Brad,
And,
what do you consider thick in this context?
we say anything greater than 5 millimeters. Under 5 millimeters tends to not be a problem. As it gets thicker, it can become more of a challenge. But the challenge is very easy to overcome, but just with patience, just debind more slowly. And so a trick you can do is to not fill it 100%, fill it at 90%. That'll leave some gaps in the infill and room for the gases to escape. The material settings. So these vary from 210 to 245. And part of the reason they vary is that everybody's printer is running higher or lower than they realized. It's rare for these to be perfectly calibrated. In fact, this machine is probably running about 10 degrees cooler than it actually is here. But experiment, this is bronze at 245. Our stainless materials, you want to be back more around 210. But copper and bronze, we're running really nicely at 245.
So we're typically guiding people to start with 210 for their nozzle temperature and then adjust from there as you look at how the print's coming out.
Right. And there is no one answer, but it's because of the variability in everybody's systems. These printers are massively different. And the situations they run in are different, the environment, the ambient temperature, things like that. So pick something and build on it. So build plate temperature, 40 is fine. You can run without it. The rest of these are not significant. So again, that's all just the PLA defaults. Speed, this is a common question. I like to run these at 60. 60 millimeters per second is a nice even number. Once things get smoothed out and the print is going along nicely, I'll sometimes on the printer move it up to more like 80, but 60 is a comfortable number. And for your initial layers, go 40. Just go nice and slow. And in 3D printing, it's true that the first layer is the most important when you're starting your print. And I think this may even be more true with our metal infused materials. So go slow, get the first layer, and adjust from there. Over extrusion and under extrusion are pretty common problems, and we'll show some pictures of that. But the most common problem that people have with our material, here, I'm gonna stop sharing for a moment, is that on their first layer, they'll have the nozzle too close to the bed. So the bed is literally clogging the nozzle is the effect.
So it can look like the material, it can look like it's a filament clog in the nozzle, but it's actually the nozzle being too close to the print bed.
Exactly. The bed is actually preventing the material from flowing through the nozzle. And you can check this quick by, depending on what your printer is, just move the bed down a little bit and make sure material is flowing. But this is by far the most common problem, or the most common issue that people run into. And with PLA has a very low viscosity, so it'll squeeze out and flow. It won't do this. Our materials have so much metal in them that they flow more like a bread dough, is an easier way to picture it. So if you picture trying to shove bread dough through a straw that's in contact with the table, you kind of get an image of what's happening.
What does it look like if the nozzle is too far away from the print bed?
What happens is it'll look like a row of rodent droppings, is the analogy that I've come up with.
Great.
Because they won't attach to the bed, and they'll come out of the nozzle and just sit on the bed. And this can be caused by two different things. One, the layer height could be too high, or your nozzle isn't calibrated to be low enough on the bed, or your flow can be too low. So you'll actually get the same symptom either way. But if the material is not attached to the bed, and what you have to do, and this is true of all 3D printing, not just our materials, but picture using that nozzle to push it into the bed. That's how you get the adhesion of the first layer. And in every case, the first layer is the key.
So how do you know when that position is just right?
This is sort of an industry situation with 3D printing. So do some research on, you can adjust it by baby stepping, like in some of the firmware, you can literally move it by just 1/100th of a millimeter by clicking a button. This is a good way to bring it into tune. But yeah, it's a huge topic. Bed leveling and nozzle height are huge. And don't shy away from it. Just attack it and make sure that you understand it.
So yeah, we have a few more settings to cover.
So speed, not crucial, slow it down. As you gain experience with it, you can print as fast as you can with plastic. Travel, this is unimportant. Cooling, you can actually shut this off. We typically run without any cooling, and most of our printers don't even have cooling fans on them. And I'll talk about this a little bit. For example, copper is a really, really good conductor of heat, many, many, many times better than plastic. So one of the challenges with PLA is removing the heat energy from the print edge as you're going. This is much less of an issue when you're working with the metal composites. They all tend to conduct heat way better than plastic. So cooling the part tends to not be an issue. We don't do much with that. Build plate adhesion, again, I print a skirt, which is just a line that goes outside of the print, but not for bed adhesion. I do that just so it prints a few lines, and that gives me a few seconds to make sure that that first layer is tuned in before it starts printing on the part itself. And the rest of it it is not important. It just prints like PLA. Set up for PLA, slow it down a little bit, warm it up a little bit, and you may find it necessary to, in the material, exaggerate the flow rate slightly. The flow rate setting, we often find that you should set it anywhere from 125 to 135. This is another setting that it seems like it shouldn't be arbitrary, but it is. It changes from one printer to the next. It changes from one version of the firmware to the next. It changes from one slicer to the next. So we recommend that people start 125 to 135% and adjust from there.
And how important is the retraction setting?
Yes, retraction is actually very important. What's important is that you don't use it. We typically, if this is turned on, we'll turn it down as low as a 0.5 millimeter. But again, with the composite materials, sort of what happens with PLA is it has a high coefficient of expansion. As it warms up, it gets much, much bigger. And that's partly why you have ooze issues with PLA, and you don't with the metal composites. They can't expand. It's copper or it's metal. So very, very low coefficient of expansion. So you can either shut this off if you find that you are having issues, turn it on, but don't go any further than 1 millimeter. We typically set it to 0.5. The reason, the retraction, what happens is the gear, the drive gear that's moving the material forward. I'm gonna hop out of here. The gear that's driving the material forward, if you have the retraction on, it'll move the material back and forth between that pinching gear so many times that it'll slowly flatten it out. And then you'll have issues that present as a clog, but they're not actually a clog. It causes a thin spot in the filament where the drive gears are no longer able to move it forward.